In general, structural mechanics involves the determination of unknown forces on a structure or body. The approach taken in this analysis depends initially on whether the system under consideration is statically determinate or statically indeterminate. For a statically determinate case, the number of equations available from the statements of equilibrium is the same as the number of unknown forces, and hence they can be solved. If the number of unknown reactions or internal forces is greater than the number of equilibrium equations, then the problem is said to be statically indeterminate. There are three classes of frame or truss. First one is mechanism. If there are more equilibrium equations than unknown forces or reactions, the system is unstable and not a structure, but is called a mechanism. The next one is statically determinate. In the statically determinate case, for which there are the same number of equilibrium equations as unknown forces. If any member is removed, then a part of the whole frame will collapse. Next one is statically indeterminate. In the statically indeterminate case, in which there are more unknown forces than available equilibrium equations, there's at least one member more than is required for the frame to be statically determinate. Here you can see three structures. The first one is a mechanism. When you apply a force to the mechanism, what will happen is that it won't behave as a structure, but will actually move or fall over. The second case is a statically determinate structure. Here we have just the correct number of components to make the structure behave as structure, i.e. take a load or weight and transfer it through to the supports at the bottom. If you were to take away one element, then the structure becomes a mechanism and then would collapse. The last one here we have is statically indeterminate. Here in this structure, we have more items or components than we actually need. So if you were to apply our force or load onto a structure and still take away one element, it would still behave as a structure, i.e. take the load and transfer it through to supports. To be able to determine which sort of structure you actually have, you need to count up the number of members, reaction forces and joints. For a mechanism, the rule is M plus R is less than 2J. M for the number of members, R for the number of reaction forces and J for the number of joints. For a statically determinate case, the rule is M plus R equals 2J. For a statically indeterminate structure, the rule is M plus R is greater than 2J. In our first case, the mechanism, members, we have 1, 2, 3, 4 members. Number of reaction forces, remember a fixed support gets replaced by 2 reaction forces. A roller support gets replaced by 1, so in total we have 3 reaction forces. Then number of joints, 1, 2, 3, 4 joints. M plus R is 4 plus 3, that gives you 7. 2J is 2 times the second 4, it gives you 8. 7 is less than 8, m plus r is less than 2j, hence a mechanism. In the second case, statically determinate, m, r and j, number of members we have are 1, 2, 3, 4, 5. Number of reaction forces we have, again, 2 for a fixed, 1 for a roller. Total we have is 3. Number of joints we have, 1, 2, 3, 4. 4 joints. M plus R is 5 plus 3 gives you 8. 2j is 2 times 4 and it also gives you 8. M plus R equals 2j, therefore it is a statically determinate structure. In the last case, statically indeterminate, M, R and J. Number of members we have, 1, 2, 3, 4, 5, 6. Number of reaction forces, fixed is 2, a roller is 1, giving us a total of 3. Number of joints, 1, 2, 3, 4. M plus R is 6 plus 3, giving you 9. 2j is 2 times 4, gives you 8. 9 is greater than 8. M plus R is greater than 2j, therefore a statically indeterminate structure. For the analysis and frameworks, you can only do the resolution of joints method with a statically determinate structure. In this example, we're going to count out the number of members, the number of reaction forces, and the number of joints. So for the number of members, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 members. R for the number of reaction forces. Remember, a fixed support gets replaced by 2 reaction forces and a roller gets replaced by 1. So we have 1, 2, 3 reaction forces in total. And then J for the number of joints. 1, 2, 3, 4, 5, 6 joints. M plus R is 9 plus 3, which gives you 12. 2j is 2 times 6, which is also 12. 12 equals 12 on both sides, therefore M plus R equals 2j, hence statically determinate. In this example, we're going to count out the number of members, the number of reaction forces, and the number of joints. For the number of members, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. The number of reaction forces, fixed support gets replaced by 2. And a roller support gets replaced by 1. So we have a total of 1, 2, 3 reaction forces. Number of joints, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. M plus R, 16 plus 3, that gives you 19. 2j is 2 times 10, which gives you 20. 19 is less than 20. m plus r is less than 2j, hence the structure is a mechanism. In this structure, we're going to count out the number of members, number of reaction forces, and the number of joints. Number of members: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Number of reaction forces: fixed supports get replaced by 2 reaction forces. The reaction forces: 1, 2, 3, 4, 5, 6. Number of joints: 1, 2, 3, 4, 5, 6, 7, 8, 9. M plus R is 14 plus 6 gives you 20. 2J is 2 times 9, it gives you 18. 20 is greater than 18, therefore M plus R is greater than 2J, hence statically indeterminate structure. In this structure, we're going to count out the number of members, the number of reaction forces, and the number of joints. For the number of members, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Number of reaction forces: fixed support gets replaced by 2 reaction forces. Roller support gets replaced by 1, giving us a total of 3 reaction forces. Number of joints: 1, 2, 3, 4, 5, 6, 7, 8. M plus R is 13 plus 3, that gives you 16. 2J is 2 times 8, gives you 16. 16 is equal to 16, therefore M plus R equals 2J, hence statically determinate structure. In this structure, we're going to count out the number of members, number of reaction forces, and the number of joints. Number of members: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Number of reaction forces: fixed support gets replaced by 2, a roller support gets replaced by 1, 1, 2, 3, 3 reaction forces. Number of joints: 1, 2, 3, 4, 5, 6, 7, 8. M plus R, 12 plus 3 gives you 15. 2J is 2 times 8, gives you 16. 15 is less than 16, therefore M plus R is less than 2J, hence the structure is a mechanism. this structure, we're going to count out the number of members, number of joints, number of reaction forces. Number of members: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Number of reaction forces: fixed support gets replaced by 2, a roller support gets replaced by 1. 1, 2, 3, 4. 4 reaction forces. Number of joints: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. M plus R: 27 plus 4, giving you 31. 2J is 2 times 14, gives you 28. 31 is greater than 28, therefore M plus R is greater than 2J, hence statically indeterminate structure.